Guys, it's Miss Maneely, and I'm going to go ahead through your Unit 7 periodic functions review for the unit test that you're going to have this week. In the first section, actually the first two sections, we are simply converting from degrees to radians and radians to degrees. So remember, the interior angle measure is what you're given, and you want to be able to convert it back and forth. So in the first three problems, you're given the degree measure. If you want to convert to radians, that's when you're going to be multiplying by pi over 180. So remember, if you don't have a pi in your original problem and you want to get it into radians, and that means you need to multiply by the fraction that has the pi on top. In the bottom, if you're given the number with a pi in it and you want to get it into degree mode, then you want to multiply by 180 over pi, and that way when you multiply, your pi's end up canceling. The other thing you have to pay attention to, though, is that all of your answers should be on the unit circle. So all of your measures in radians should be between 0 and 2 pi, and all of your degrees should be between 0 and 360. Well, between 0 and 360 is easy enough to identify. The radians are a little bit harder, so it's easier to convert them to degrees first and then to move it around. So in number 1, it's pretty straightforward, 255 degrees. If I want to convert it to radians, I'm just going to go ahead and multiply by pi over 180. And on my calculator, this is like having 255 over 1. So if we use our calculator, we're simply taking 255, and since the 180 is in the denominator, it's like dividing by 180. Now when I do this, I'm going to get a decimal answer, but I can change it back to a fraction by hitting my math button. And the very first option will change it back to a fraction for me. And I get 17 over 12. Now don't forget, you still have a pi, so it's going to end up being 17 pi over 12. We're just using our calculator to help us with the fraction part. In number 2, we're starting off with 712 degrees. Well, 712 degrees is way beyond 360, so we have to adjust it first. And we adjust it, since it's too big, we subtract 360. So if we take 712 and subtract 360, we get 352. And 352 is on the unit circle. So if I multiply by pi over 180, I'm basically going to take the 352 and divide it by 180. And actually, at this point, you can even go into your math menu and choose the fraction, and it'll just give you the entire result as a fraction. And that's a strange-looking fraction. We've got 88 over 45, and that's actually going to be 88 pi over 45. In number 3, we're starting off with a negative 140 degrees. So I've got to fix it by adding 360. So when it's too small, you need to add 360. So negative 140 plus 360. And that gives us 220 degrees. And when I multiply that by pi over 180, I'm going to take my 220 and divide that by 180, and then adjust my answer so it stays as a fraction in lowest terms. And that's going to be 11/9, or 11 pi over 9. Okay, when we get down to the next section, like I said, if you have a pi in your original problem and you want to get rid of it, then you multiply with the fraction by the fraction that has the pi in the denominator. And now I'm just going to multiply through. So I've got a fraction 9/4, and I'm multiplying that by 180. So I'm just going to do 9 divided by 4 times 180. And this time I get 405. Now that is now going to be 405 degrees. Well, 405 degrees is bigger than it's allowed to be, so I need to make sure that I subtract 360. My calculator's not picking up my hands. There we go, 45 degrees. I can do the same thing with number 5. If I multiply by 180 over pi, the pi's are going to cancel. I'm basically taking 11 divided by 6 and multiplying that by 180. And I get 330. So that would be 330 degrees. And that is on my unit circle, so that's fine. And number 6, notice there's a negative. We're going to keep the negative there for a minute and multiply by 180 over pi. My pi's will cancel. And I'm going to go ahead and keep the negative in my answer, so it's going to be a negative 13 over 8. And then I'm going to multiply that by 180. And I get a negative 292.5. Okay, so I'm not allowed to have a negative degree, so I'm going to add 360 to that. And when we're dealing with degrees, it is okay to have a decimal in your answer. And so our final answer would be 67.5 degrees. Okay. The next section deals with arc length. We have a formula that basically tells us that the arc length of a sector is equal to theta times the radius, where theta is measured in radians. So if we take a look at number 7, it says to determine the measure of the central angle of a sector that has a radius of 26 and an arc length of 5 pi over 4. So what we're given here is our r value, which is 26. And if we know the arc length, that's actually an s value, which is 5 pi over 4. So if I plug these values into my formula, remember it's s is equal to theta times r. My s is 5 pi over 4. I don't know the value of theta, and r is 26. If I want to solve for theta, think of it as just being x. If I had something like, I'm just going to change it for a second. If I had, 5 is equal to 26x, I mean, that's essentially what this is. I would simply divide both sides by 26, and that would enable me to solve for x. Well, this time my unknown is theta. I can still divide both sides by 26, which is the same thing as multiplying by 1 over 26. And when I do that, the 26's are going to cancel over here. And just like what I did in the previous section, when I plug this into my calculator, I'm going to leave the pi alone, and I'm going to take, let's see, 1 over 26, and I'm going to multiply that by 5 over 4. And we get a nasty decimal, so if I change that back to a fraction, I get 5 over 104. So that means that theta is going to be 5 pi over 104. I think this problem is probably more complicated than the one on the test. What you're going to see on the test is something where, let's say, you have a central angle or an interior angle. Let me do it this way. Interior angle. Let's say it is, I don't know, 3 pi over 2. So that gives us our theta value. And let's say we have a diameter of, I don't know, let's say 16 centimeters. And I want to find the length of the arc. Well, first of all, my formula requires that I use the radius. So the first thing I'd need to do is change my diameter into a radius. And remember, the radius is half the diameter. So I'd have a radius actually of 8 centimeters. And if I want to find the length of the arc, or the arc length, I'm just going to multiply theta, which we said is 3 pi over 2, times my radius, which is 8. So that's really the type of problem that you're going to be seeing. And again, if I'm going to just leave the pi out of my answer for a minute, and I'm going to take 3/2, and I'm going to multiply that by 8. And I end up with 12. So when you're writing your answer, don't forget that there's still a pi. So it's going to be 12 pi. And then you also want to make sure you include your units with your answer. So this is really what the problem is going to be more like on your test. I'm not even going to bother with number 8 because that's a little bit harder than the one on the test as well. So if you can do the example that I just threw out there, then you should be good to go for the test. All right, this is just a copy of the unit circle. I'll come back to this in just a second. The next couple of examples that we're going to do are going to refer back to the unit circle. So in problems 9 through 11, it just says to determine the point on the unit circle excuse me, that corresponds to the central angle. So all you have to do is find, for example, in number 9, find 2 pi over 3, and figure out the ordered pair associated with it. So let's go back to that unit circle and find 2 pi over 3. 2 pi over 3 is right here, and so the coordinates associated with that angle are given as -1/2 and the square root of 3 over 2. And that's really all you're asked to do here. Okay. In number 10, though, you're given a negative angle. It says negative 45 degrees. So you do have to remember that when an angle is negative, instead of going counterclockwise around the circle, you're going clockwise around the circle. So if I think about what a 45-degree angle is, this is a positive 45-degree angle. So a negative 45-degree angle is just going the other way. So a negative 45-degree angle is going to be equivalent to 315 degrees, and the coordinates associated with that point are going, or that angle, are going to be the square root of 2 over 2 and negative square root of 2 over 2. Okay, and then number 11, notice you're given theta is equal to 7 pi. Well, 7 pi is not on my unit circle. I've got 0 pi. If I go halfway around the circle, that leads me to 1 pi. If I go all the way around, that's 2 pi. Well, I can keep counting. If I go around again, that's 3, 4, 5, 6, 7. And so 7 pi is equivalent to 1 pi. And the ordered pair associated with that point is negative 1, 0. And so if you can figure out the coordinates of the point associated with the angle, then it makes evaluating functions like in 12, 13, and 14 much easier. So for example, in number 11, if I had said, well, what is the cosine of 7 pi? If you know what ordered pair to refer to and can remember that cosine corresponds to the x-coordinate, the cosine of 7 pi is simply negative 1. So let's take a look at number 12. It says, what is the cosine of 5 pi over 6? So what I need to do is find 5 pi over 6 on my unit circle and pick out the cosine. So 5 pi over 6 is right here. And I want the cosine of the ordered pair associated with that angle. And the cosine, remember, is the x value. So it's going to be negative square root of 3 over 2. Okay. If you forget how to do that, let me show you another way that you can do this on your calculator. Notice that 5 pi over 6 is a radian measure. So if you go to the mode section on your calculator, you want to make sure that the third line indicates that it's in radian mode. And so then if you go back to your home screen by doing second mode or second quit, you can evaluate the cosine. So I can look at the cosine. Now this time I do want to put in the pi. I do 5, and then my pi button is above the caret feature, divided by 6. Now this is going to give me the answer as a decimal, and it ends up being negative 0.866. Well, if I take the negative square root of 3, make sure the negative is on the outside, and then close out your square root before dividing by 2, and I press enter, I'll see that it's exactly the same number. So if you get stuck on the test next class, you can also use your calculator to check for that as well. Let's jump to number 13. We're asked to find the tangent of negative pi over 4. Well, let's first find negative pi over 4. Negative pi over 4, and actually let me clean this up a little bit. Let me erase this circle. So negative pi over 4, since I'm going in the negative direction, if this is positive pi over 4, then I want to go in the negative direction, which is going to put me at 7 pi over 4. And the coordinates associated with this point are the square root of 2 over 2 and negative square root of 2 over 2. So let me just kind of keep that in mind. It's the square root of 2 over 2 and negative square root of 2 over 2. This is my x value. This is my y value. And what I hope you can remember is that tangent is going to be the y value divided by the x value. So if we think of it as negative square root of 2 over 2, I mean, if I want to write it as a fraction, I would simply write then underneath the square root of 2 over 2. Now, if you look at this, I know it looks a little crazy to see a fraction over a fraction, but this fraction and this fraction are the same fraction. And anytime you divide a number by itself, it should cancel to 1. The fact that there's a negative out in front should tell you that this is going to reduce to negative 1. If you forget how to do it, you can certainly put this into the calculator. You just want to make sure you have parentheses for the numerator. So I'm going to have negative square root of 2. Make sure you pull your cursor out of the square root before dividing by 2. Close that parenthesis and then divide by another square root of 2. divided by 2. Okay, so that would be another way that you can check. The sine of 405 degrees. Well, notice that 405 degrees is beyond 360. So do what we did in the first section and subtract 360 to figure out what angle we're dealing with. So 405 minus 360 leaves us with a 45-degree angle. Okay, so really what I'm trying to do is find the sine of 45 degrees. And that's just the y value of 45 degrees. So if we go back to our unit circle, here's my 45 degrees. And if I'm asked to find the sine, that means I'm looking for the y coordinate of that point, which is the square root of 2 over 2. And that's how you would evaluate those functions. Okay, so notice in these problems, you're given the value of theta. You're finding the cosine of 5 pi over 6, or the tangent of negative pi over 4, or the sine of 405 degrees. In the next section, you're not given the angle, you're given the value of the function. And so you have to work backwards. So this is going to require that you construct a triangle and use your SOHCAHTOA relationships to figure out the missing function. So number 15, it says, suppose that the cosine of theta is equal to negative 3/5 and that theta is in quadrant 3. Both of those pieces of information are going to be very important to you. When you're constructing the triangle, it will help simply to just draw a right triangle. I'm going to call this theta since this is my right angle. And if I'm dealing with cosine, so think we've got, this is our opposite side, this would be our adjacent side, and this is our hypotenuse. And if you think about SOHCAHTOA, the ka part refers to our cosine and tells us that the cosine is equal to the adjacent over the hypotenuse. So if I'm told that the cosine of theta is equal to negative 3/5, then that's going to correspond to the adjacent side over the hypotenuse. Okay, I'm going to ignore the negative for a minute. Basically, that tells me that the adjacent side is going to have a value of 3, and my hypotenuse is going to have a value of 5. So let's figure out the value of my opposite side. To do this, I'm going to use the Pythagorean Theorem. I know that 3 squared plus, let's just call my opposite side x squared, has to equal my hypotenuse squared, which is 5 squared. Or 9 plus x squared equals 25. And if I subtract 9 from both sides, I get that x squared is equal to 16. And if I take the square root of both that, I get that x is equal to 4. Now, x could also be negative 4, but since I'm dealing with the length of a triangle, I'm going to keep it 4 for now. But do remember, it could be negative 4. And that's where this piece of information comes in handy, that it tells us that we're in quadrant 3. So at this point, since I'm trying to find the value for the sine of theta, I know that sine, if I go back to my SOHCAHTOA relationship, sine is equal to the opposite over the hypotenuse. So the sine of theta has to be equal, the opposite side in this case would be 4 over the hypotenuse of 5. But it also has to be in quadrant 3. So if we go back to our unit circle, in fact, you know what? I don't need to go back to my unit circle. I can draw the quadrants right here. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Remember that sine refers to your y value. So if I think about the sign, positive or negative, of my values, if I am in quadrant 3, that means my x value is negative and my y value is negative. So if I'm trying to find the sine of an angle, the sine, which corresponds to my y value, must be negative. So I've got to remember to make sure that the sine of theta in the third quadrant is negative. If you forget that on the unit circle, it tells you the positive functions are going to be tangent and cotangent. All of the others are going to be negative. Sine is negative, cosine is negative. We didn't talk about secant or cosecant, but both of those functions would also be negative. Okay, so let's do number 16. In number 16, you're given that the sine of theta is equal to 5 over 13. So if the sine of theta is equal to 5 over 13, this time, again, we're dealing with our sine function. 5 must be my opposite side, and 13 must be my hypotenuse. So if I draw a triangle, and this is theta, then I know that 5 must be my opposite side and 13 must be my hypotenuse. And I'm trying to figure out that value there. So that means that x squared plus 5 squared, and this is actually one of your perfect triples. So x squared plus 5 squared has to equal 13 squared. Or x squared plus 25 is equal to I think it's 169. Let me just double check. Yep. And so if I want to solve for x squared, I'm going to subtract 25 from both sides. And then we'll have that x squared is equal to 144. And if you take the square root of 144, hopefully you recognize that as 12. Now it could be negative 12, so we've got to pay attention to what quadrant we're in. Since we're asked to figure out the value of the tangent of theta, remember tangent in SOHCAHTOA is going to be equal to the opposite over the adjacent. The opposite side in this case is 5, and my adjacent side is 12. So the only thing left for me to do is to figure out if tangent is positive or negative in quadrant 2. So let's just jump back to our unit circle since you have it. If I'm in quadrant 2, figure out where your tangent function is, and it tells you that tangent should be negative in quadrant 2. So that tells me that the tangent should be negative. All right. The next section, you guys have done really, really well with graphing. So in number 17, you're given a graph of a sinusoidal function, and you're asked to come up with equations based on where the cycle starts. So remember, with all of these functions, the amplitude and your midline is going to be the same for each of them. So I can see the midline is right here at y equals 2. So that's going to be my midline. And that basically means that, my k value for each of these functions is positive 2. I can also figure out my amplitude from there, because if this is my midline and this is my max, there's a difference of 4. I can also double check and make sure that there's the same distance to my min. So that means my amplitude is 4. So I'm going to have y equals 4, y equals 4, y equals 4, y equals 4 for all of them. The next thing I want to do is think about my function a, or where my point is starting here on letter A. Because it's starting at the midline, I know I'm dealing with a sine function. I also know that my graph is going up first, so it's not reflected. It's going to be a positive sine function. The only other thing I need to figure out is where it starts on the x-axis. Where does the cycle start? It starts at negative 7 pi over 3. So that corresponds to the h value. If you remember, so if I have y equals a times the sine, it's going to be theta minus h plus k. So the h value in this case is a negative 7 pi over 3. But when I put it into the parentheses, because that minus sign is already there, it's telling me to take the opposite of h. So I'm actually going to put in theta plus 7 pi over 3. And I'm going to do that for each value. So if I take a look at letter B, I can see that B is now starting at the min. So if a function starts at the min or at the max, it's got to be a cosine function. The fact that it's starting at the min tells me it's been reflected, so I need to put a negative there. The next thing for me to do is to figure out where the cycle starts on the x-axis. But when I go up to the x-axis, I don't see a number there, so I've got to figure that out. So if this is 0, and this is pi over 3, that means that this value in here is halfway, and that would correspond to pi over 6. So each of those little marks corresponds to pi over 6, or 1/6. So if I count backwards, so this is 1, 2, 3, 4, 5. So this value here is negative 5 pi over 6. And since it's negative, when I put it into my parentheses, I need to change the sign and make it opposite, so it'll be plus 5 pi over 6. Okay. The next one, letter C, starts at the top. So again, I'm dealing with a cosine function. Since it's at the top, it's not reflected, so I don't need to worry about changing the sign. And again, if I notice, it starts at pi over 6. So this time when I put it into the parentheses, I need to do theta minus pi over 6. And in letter D, I'll do this in red, D starts in the middle. So I know I'm dealing with a sine function. Since it goes down first, that tells me that my sine function has been reflected, so I need to make my coefficient negative. And I also need to figure out where the cycle starts, and that's at 2 pi over 3. So in parentheses, I'm going to do theta minus 2 pi over 3, and that's how I'm going to do that problem. 18, 19, and 20 are our applications. So number 18 says the following equation gives a model for the depth of the Mississippi River over time in hours. And so it says, according to the trigonometric model, what is the average depth of the Mississippi? So I could graph this, and I might need to do that. Let's see, I might actually need to do that for letter B. But if I remember, this value here corresponds to my midline. And this value here corresponds to my amplitude. And so if I'm drawing a graph, it means that basically the depth of the water is going to go up and down around that 156. But that 156 is going to be the average depth. So just remember that your midline, the midline represents the average depth. And that would be 156.29, and the depth is in feet. So make sure you use units. In letter B, it says, in order for a barge to travel safely on the Mississippi, the water needs to be at least 160 feet. During what time intervals is it safe for the barge to travel the Mississippi? Okay, so in this case, let's go ahead and plug our equation into y equals. If you notice, I've got a plot highlighted, so if I go up, if I push my arrow up and press enter, it'll turn the plot off, and I'm going to need to do that before I enter my function. Now I can go ahead and type in 8 times the sine of 0.5t, or in this case, I'm going to type in the x plus 0.02, close my parentheses, and add 156.29. Okay, so I need to set my window. So if I go to my window settings, I know that time is measured in hours. So I really only need to go from 0, and then my x max should be 24. And then the water depth, if the average depth is 156 feet and the amplitude is 8, that means from 156 it could go up 8 or down 8. So if I rounded that, I could probably make my maximum for my y window to be maybe like 170. So let's go ahead down to where it says y max and type in 170. Keep your mins both at 0. And then go ahead and hit graph. The only other thing you want to double check, so if you see like a horizontal line, you want to go to your mode and double check to make sure that your mode is set to radians. For all word problems, you want to make sure your mode is set to radians. So here's the graph. And in letter B, it says the water must be at least 160 feet deep. So I need to figure out where 160 feet is. If I go into y equals, since that's going to be corresponding to the depth, I can type in another equation for 160 feet. And when I graph it, I can see. It's a little hard to see, but basically, looks like I've got this kind of wave pattern here, and then here is the 160. And I want to figure out during what intervals it's safe for the barge to travel on the Mississippi. So I can see that the graphs intersect at those two spots and at those two spots. And so between them, the water's deep enough. It's over 160, and it's over 160 here. So this is where you use your intersect command. If you go to second, trace, and choose intersect, which is option 5, we want to scroll back. Now this is really hard to see, so actually I would suggest maybe adjusting the window a little bit more. If we go to our window setting, I'm actually going to change my Y min, in this case, to 150. And let's do our Y max to be 200. And that'll just kind of format the window so that you can see that wave in the middle of the screen. And hopefully it might be a little bit easier to see that way. So now when I go to second, trace, and choose my intersect, it's a little bit hard to see. You want to use your left arrow there we see it, and scoot all the way over to that first intersection point. And once you get there, whoops, I went a little too far. Once you get there, if you press enter, Press it 3 times. As long as you're really close to the first intersection point, it'll calculate it for you. And so that first intersection point occurs at 0.92. And then we can do that again. If we hit second trace, option 5, we can move the cursor over to the second point of intersection. And my calculator keeps going a little too far. Press enter until you see the word intersection. And that occurs at 5.28. So I know right now between 0.92 and 5.28 hours, and that will be after midnight. And now I have another time interval where the barge can safely pass. So if I hit second trace again, choose option 5, and then move my cursor as soon as I get it close to that next point of intersection, I'm going to press enter until it says intersection, and that is at 13.49. And the last one I do, second trace, choose option 5, and then move to that last point of intersection and press enter until it says intersection. Did I push it too many times? Okay, 17.85. Okay, so between 0.92 and 5.28 hours, and then again between 13.49 and 17.85 hours. So if you were talking in terms of like military time, like 13 hours would be 1 o'clock in the afternoon. 17 hours would be like 5 o'clock in the afternoon. So there's a time period in the morning where the tide is going to be high enough for the barge to pass, and then there's going to be another time in the afternoon where the tide is high enough for the barge to pass. Okay, number 19. This is a Ferris wheel problem. These are fun. A Ferris wheel sits 368 feet in diameter and makes a revolution every 422 seconds. That's relating to the period of the function. The center of the wheel is 400 feet above the ground. Well, if you remember, if I draw a Ferris wheel, here's the center. If the center is 400 feet above the ground, that's going to correspond to my midline. And if I know that the diameter is 368, then the radius must be half of that. And the radius is going to correspond to my amplitude. So if we go to our home screen, 368 divided by 2 gives me a radius of 184. Okay, and so the radius tells me my amplitude. So this is my amplitude. Okay, the 400 feet is my midline. And so if I wanted to write my equation, I know that h of t, I'm not going to change the negative, it's going to stay out there. My amplitude is 184, and then I'm going to have times the cosine of 0.015 t plus my midline, which we said is at 400. So that's how I would get the equation for the path of the Ferris wheel. If I want to figure out the maximum and the minimum height, which, let's see, well, I guess in letter B it's just asking for the maximum height, I need to use my amplitude. So 400 plus, so if I wanted to go up here, I'd need to add 184. And so that would give me a maximum of 584. I could also subtract if I want to find my minimum. So let's go ahead and do that. 400 minus 184 is going to give me a minimum of 216. So this thing is pretty high off the ground. Okay, so it says, what is the maximum height above ground? So our maximum we just figured out is going to be 584. Make sure you use appropriate units. And it says, how long will it take passengers to reach the maximum height? So remember, they're getting on here. So this is where the ride starts. It starts at the bottom. And we know that it takes 422 seconds to go all the way around. So if they're just going to reach the maximum height, notice they're only going halfway around. So I really only had to get the time. It would just be 1/2 of 422. And that would be, so 0.5 times 422 would be to 11. And that would be in seconds. Okay. And then in letter C it says, how long would it take passengers to reach a height of 400 feet above ground for the first time? So if this is where I'm getting on, and this is where they're going to hit 400 feet, notice that's a quarter of the way around the Ferris wheel. So I would just need to do 1/4 times the period of 422. And so if we do 1/4 or 0.25 even, if you want to use that, we get 105.5 seconds. All right. And then the very last question, number 20, is very similar to numbers 18 and 19. So I'm actually going to let you guys do number 20 on your own. This is, again, where you're going to want to graph the function. Let me give you window settings, though, to help you out. So you're going to want your x min to be 0. And let's see, we're looking at the monthly sales. So I believe we're going to be looking at 1 year. So our x max would be 12. Our x scale, we'll keep it at 1. Our y min, we'll keep it at 0. And let's use a y max. And the way I'm able to figure this out, if this is my midline and this is my amplitude, my maximum is going to be the sum of those two numbers. So I've got a number around 62 and I'm adding a number about 38. It's going to give me something a little bit over 100. So to be on the safe side, I'm going to let my y max be 110. So go ahead and see if you can do that by yourself, and you can check your answers with me right before the test. Good luck, you guys.